Hello ladies and gentlemen, welcome to Mishler Math, and let's take a look at how to graph a simple linear equation. And the equation I'm going to graph, by the way, is if you look at page 6, okay, there's a example there that goes through how to graph y equals 2/3 x minus 1, and underneath that it says try this, okay? So try this is graph y equals 5/4 x plus 3. Now you might remember from your the old days in algebra 1, okay, the slope-intercept form, like y equals mx plus b, and of course this is your intercept, your y-intercept, and this is your slope, okay? M is slope, b is y-intercept. And so if my y-intercept is 3, let's take a look at what that means. This is my y-intercept, so I go to the y-axis right here, and I go up 3 units. And there I go, there's y equals 3. Okay, so that's my y-intercept. My slope, if you remember, the slope, 5/4, let me get something that's a little easier to see there. 5/4, that means up 5 and to the right 4. So if I start at the point that I just put there, if I go up 5 units, 1, 2, 3, 4, 5, and to the right 1, 2, 3, 4, and put another point, well, you know that 2 points make a line. Or if I want to, I can go start here, and I can go, remember this is also equal to minus 5 over minus 4. So I can actually go down 5 and to the left 4. So let's see what that looks like. If I start here, I go 1, 2, 3, 4, 5 down, 1, 2, 3, 4 to the right, or to the left, I mean. And so now I could actually draw a line, and let's make it a nice red line, through these 3 points, okay? And that will be the graph, and I am going to do this again, and one of these days, by golly, I'm going to get this right. That's not the right way to do it. Okay. So there's the graph of the equation y equals 5/4 x plus 3. Well, there's a couple other things we need to learn about from this chapter before we can do the homework assignments, or one other thing mainly, and that is how to tell if we have a linear equation or not. So if we get a set, for example, the old t-table. If we get a t-table, and I'm going to draw some vertical lines here and kind of make it look like a number line, only it's not. It's going to be a table. There's your x values, okay, and there's your y values. And again, I'm doing the try this below the example on page 7. So if I start with -2, 2, 6, 10, 14, and 18, like it shows it there, and underneath that I have 1, 2, 4, 8, 16, and 32. Now, if you look at the top here, you're going to have to look at how did I get from here to here? I added 4, didn't I? -2 plus 4 is +2. Okay? 2 to 6, I add 4. 6 to 10, I add 4. 10 to 14, add 4. 14 to 18, add 4. On the bottom, 1 to 2, I added 1. Here, I added 2. I added 4. I added 8. And from 16 to 32, I had to add 16. So obviously, we don't have the same thing. We have the same thing here on the top. However, we also have to have the same thing here on the bottom in order for this to be a linear equation. So it's very, very simple. You just look at this and you say, well, I don't have the same change. The rate of change is different on the top, or it's the same on the top, but it's different on the bottom. I'm adding 1, adding 2, adding 4. So this is not a linear relationship. Oh, that's, I guess, relationship. Okay, not a linear relationship. So let's take a look at another table here. And I'm going to choose another color here. Maybe this one will work. And let's see. Nice, beautiful straight lines. I'm getting so good at this. And I'm just going to wing it on these instead of trying to make those nice, beautiful straight lines. All right, we got another table here. This is X and this is Y. Here I have 9, 6, 3, 0, -3, and -6. And I don't need the rest of this stuff anymore. So I'm just going to leave that there. So on the bottom I've got 5, 5, 5, 5, 5, 5, okay? And now this might be a little confusing because 9 to 6, you -3, or you subtract 3, subtract 3. 3 to 0, you subtract 3. 0 to -3, subtract 3. -3 to -6, you subtract 3. So each time I go to the next step, I'm subtracting 3 to get to the next number, okay? On the bottom here, though, look, I'm adding 0. And so on, okay? I'm adding 0 each time because it's 5 all the way across. I'm not adding and subtracting anything. So if we look at this, let's take a look up at our graph here. In fact, I can pretty much just draw a graph right here. Let me do that. Do a graph here. And like that. Boy, I'm getting good at this, aren't I? All right, so we got 1, 2, 3, 4, 5, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? 1, 2, 3, 4, -5, 6, 7, 8, 9, -10. A little sloppy, but you get the idea. 9 and 5 are right here. Go up to 9 and 5. There's 9, 5, okay? I'm sorry, let's make that a little bit better than that. Okay, erase that and go back to our pencil. 9 and 5 right there, okay? Back up 3, you got 6 and 5 is your next ordered pair. 6 and 5, okay? And then back up 3 more, and you got 3 and 5. 1, 2, 3, and 5. And then you got 0 and 5, which, by the way, is your y-intercept. Remember, anytime your line crosses the y-axis, that means it's your y-intercept. Okay, and then back up, you got -3 and 5, which is right here, and -6 and 5, which is right here. And if I draw a line through a nice straight line through all of these points, okay? Yes, it hits all of the points. It's a straight line. So this means yes, this is a linear relationship. Now, did I need to do that graph? No, I didn't need to do that graph. All I had to do was look at this, and I've got the same rate of change here and the same rate of change here. Okay, so the same numbers changing here as they are here. Even though this number is 0, it's still changing exactly the same. For example, if this was 6 here and this was 7 here, it wouldn't work. Okay, but because it's all 5, that means that, yes, I have a straight line. Thank you so much for listening.